Hi, welcome to the Queen's Space Engineering Team. My name is Michael and I'm this year's Qubesat captain. Here on Qubesat, we tackle space and engineering problems with the ultimate goal of building a Mars rover and a 3U cube satellite. Qubesat is split into two teams, one for the rover and one for the satellite. Each team has separate members and a separate competition. I'll pass it off to the chief technical officers to explain more about the rover and satellite team structure and competition.
Hey guys, I'm Nick Mimic and I'm the CTO for Cubesat's Mars rover. We want you to be part of this year's amazing team of talented scientists and engineers working to create a fully functional Mars rover. The rover team has students from every discipline of Queen's engineering, and we value students from all years, regardless of your past experience and no matter what your skill set is. Each year, we bring the rover to the Mars Desert Research Station in Utah to compete in the University Rover Challenge. There, we complete missions with the Mars rover such as servicing equipment, traversing extreme terrain, fully autonomous navigation, and soil sample life detection. The goal of our project and the competition is to design a rover which will be able to work alongside astronauts in future missions to Mars. Let's talk about the four main subteams for the rover. The payload subteam is responsible for developing an onboard and automated science laboratory which can detect whether or not life is present in soil samples collected by the rover. The payload team also analyzes all data from the laboratory to detect the presence or absence of life in each sample. The mechanical subteam designs, manufactures, and assembles all mechanical hardware on the rover. Mech team is also responsible for any structural analysis and optimization of all mechanical components. The electrical subteam handles circuit board design, power delivery, and electrical design of the drivetrain, robotic arm, and onboard laboratory. Finally, the software subteam develops control software for all subsystems of the rover. We use a platform called Robot Operating System to control the drivetrain, arm, and laboratory from our onboard computer network. Thanks for listening. I'm going to pass it off to Josh now to talk to you about the satellite.
Hey guys, my name is Josh Wade. I'm the CTO for Cubesat's satellite team for this year. We focus on designing and building a miniature satellite called the Cubesat. For the last 4 years, our team has been participating in the Canadian Satellite Design Challenge. This is essentially a Cubesat design competition between over a dozen Canadian universities. The end goal of our team is to build and test our satellite, win grant money, and then hopefully launch it into orbit. Our design project is broken into 6 major subsystems: power, payload, comms, ADCS, onboard computer, and structure. Building any of these components on their own is hard, but putting them all together and launching that into space is a very complex and multidisciplinary engineering challenge. We're looking for passionate students who are interested in working on everything from applied mathematics to electrical engineering and mechanical design. The payload is the purpose of the Cubesat, and it can vary a lot depending on the mission. This year, our payload is a camera module, telescope, and focusing lens. The end goal is to allow the satellite to take a picture of the surface of the Earth. The power system collects energy using solar panels and stores it in a battery pack. Then it can distribute it throughout the rest of the satellite. The communication system allows for data to be sent from the ground to the satellite and vice versa. The ADCS, or Attitude Determination and Control System, allows the satellite to turn and reorient itself in space. Since we can't rely on thrusters, we have to use conservation of momentum and Earth's magnetic field to control the satellite's movement. All of the satellite's components need to be housed inside a special aluminum alloy chassis that needs to be lightweight and strong enough to protect all the other subsystems. Finally, the onboard computer is the network that connects and manages all the other components together. The satellite team is open to everyone, and we want to make sure that new members have the chance to learn and contribute to all of our projects. That's why we have a space school onboarding program, where new students can get design experience in a more relaxed and creative environment.
As you can see, Qubesat is a very diverse team with many different sub-teams, so no matter what you are interested in, there's a place for you. This year, due to remote learning, we have been working hard to shift all team operations online. We will be collaborating using Microsoft Teams so you can still connect with us from anywhere in the world. For more in-depth information about our projects, sub-teams, and satellite crash course, go check out our website at qset.ca, where you'll also find our application forms. So what do you say? Are you up to the challenge? Join us today and let's revolutionize space. Thank you, and we hope to see you soon.